Thank you, Nabil. I think we'll just dive right into it.
Okay.
So this presentation is based mostly on reflections I made during the last half year or so when reviewing Yang models from different organizations, and also in a couple of cases reviewing the standards bodies style guides. I thought it was interesting to reflect about that. So the first thing I think is important when it comes to making Yang models is to remember who all this is for. And this is Hugh Jackman from The Greatest Showman, who is towards the end of the film and starting to think about why he's doing what he's doing. And I think it's better to start with that early on when you're making Yang models. We are doing all of this work for network operators. They could be big service providers, or it could be smaller enterprises, but they are operating a network anyway. And they have different both people and equipment that is trying to operate these networks. We have, of course, human CLI operators. We have some programmers, and we have some systems like orchestrators. And I think most people make it clear and understand the clear distinction between the CLI operators and programmers. They see that, okay, this is now manual work and this is automated. But a lot of people don't see the big difference between programmers and orchestrators. But as you will see, I think that's a quite huge difference. This is actually the same sort of discussion that the auto industry has had when it comes to self-driving cars. You have the automobile, right? It's something that's automated already when you start. But when it comes to the control, it's not until recently that people have started to think about the automation of the steering and the driving. So some companies started, and after not such a long time, many companies said, yeah, we also have self-driving cars, but they actually mean a lot of different things. So after some years, the auto industry started to define some levels, and here's the Wikipedia page from that defines, oh, you mean automation to this level or to that level. So on level 1, for example, you have automation of some specific tasks or specific context, like parking or cruise control on a highway. Whereas on level 3, you can take the eyes off the road and everything will be safe, but still the system may not be able to handle all situations. It can maybe only drive inside a particular area, or when it's not snowing, or something like that. And on level 5, it's basically a taxi service. You don't have to worry about it. Somebody else is taking it all. And this is also where Yang plays. I mean, we have a lot of people that are using automation tools that are playing in the lower levels here. And that's fine too. You can certainly have use for cruise control or parking assist and stuff like that. That's not a problem. But what we are shooting for when it comes to netconf for Yang is much higher levels, at least level 3 or 4, when it comes to closed loop automation. And some of those scripts and automation tools out there just won't cut it on those levels. So I think we need to start considering having this sort of scale when it comes to network automation as well, just to stay sane and discuss the same things. So just an example here. So we have a navigation system. It depends on an ability to get the current position. It might use GPS, but also LiDARs and radars and whatnot to figure out where it is. It has a world map to see how you go from point A to point B, and somebody gives you an intent and a goal, which is, okay, I want to go to point B. And then there's the rules for how you behave in traffic. You're allowed to make U-turns here, and this is how you get through the crossing and stuff like that. And if you have all these pieces, the control algorithm can figure out what to do with your car. But this whole thing assumes that this control algorithm is working a lot faster than how you can get the current position, how often the goal changes, and how often the world map changes. In networking, you may not be able to get to current position all that often, because the current position is not just 3 coordinates, it's 3 gigabytes of data. The goal is also changing every few seconds, because there's a new customer that wants something, so the desired network layouts and services changes quickly. And the world map is also changing, because we're adding and removing network connections between devices all the time. So we have a challenge here. how can we get this control algorithm to work in an environment where things change faster than the control algorithm is able to cope with. And that's the networking situation we have. So in order to do that, or on top of that, actually, you also have to avoid some undesirable situations, just like in traffic. You don't want to collide. In networking, you don't want to get into, for example, insecure states, like setting up the connection first and enabling the firewall later is not a good idea. And also you have to do some dead counting when it comes to the networking, because you cannot really transfer the current position with equipment all the time. You have to say, okay, I knew what this device was doing a minute ago, and now I'm telling it to do this, and I have to depend upon the trust that it's going to do exactly what it did a minute ago plus what I said. And I don't need to ask exactly what it's doing now, because that takes too long. So in a world where current position is slow to get and the goal changes rapidly and the world map is also moving as we are changing as we are moving along, we need some help. And one of the biggest cornerstones for that help is transactionality. Transactionality, it's all about the acid properties as we know them. That's transaction theory. To a client, that means that it's all or nothing. Either you do this change or you don't. There's nothing in between. There's not like, I asked you to do this, it's doing half of that and half didn't work. They also means no contract violations. Whenever you read or write to something in the network, you need to be able to trust that all the constraints and rules that go with this network and the Yang models are upheld by all participants. When I tell a network to do something, there's often sequencing requirements there, or first the network needs to do this and then it can do that. But as a client, I don't want to know that. I just say, here's what needs to be done, you go figure it out. And once everything is, I've sent everything out, we've got it, okay, then it's going to be like that, no matter what, until I say something else. Because if a device goes down, it needs to resume whatever it was doing when it comes back up. It must not depend on me to say that. And the whole point with this is that it needs to be an environment that's easy enough for robots to survive in. When there are programmers around, we could work around all sorts of things. Programmers can figure out why things are not working and work around that. But if we want to have robots in this environment, it's got to be this easy. That's why transactionality is so important. But of course, all this work to make things that easy is somebody else's work. So on the server side, things are getting harder. You have to implement rollback on failure. You have to implement validation of configuration state. And that validation needs to depend only on the new config, which is even harder. And if there's any sequencing, it's up to the server to fix that and make sure that things are implemented in a particular order. And so you see the coach is sitting there and yelling at the programmer, get this done, get that done. These are the rules. It's tough. But that's what it takes. If you want to have the help of those robots, this is what we need to do. As with section 2, there's the not invented here syndrome is a disease, says Linus Torvalds, and you'll see what I mean by that in a moment. So when you're starting to use Yang or build your own Yang models, you can of course start your own Yang model that's independent of everything and doesn't refer to anything anywhere. And by that you can start your own modeling style and build your own universe. But it may also be convenient to be able to reference things that other people have done in IETF or OpenConfig or 3GPP or a couple of dozen other standardization bodies or other vendors. And there's literally hundreds of organizations that are producing Yang models these days. If you want to reference things from other vendors or other organizations, you will soon realize that they come into some different universes. We have the IETF universe. All IETF models, of course, they work together because they are using the same style and same convention, same rules. Whereas OpenConfig, they also work very well together with other OpenConfig modules, but IETF and OpenConfig modules generally do not work well together. There are some cases actually OpenConfig uses a few IETF models, but in general, it's not easy to mix models from several different universes. So you basically have to pick your own. You have to pick one of these universes, and there are more than these, of course. But This is a question. If you're a standardization body and you want to make your own universe, it's very convenient and attractive to say, yeah, I'll make my own. I'll start my own universe, because then you stay in control. You decide everything. You decide the rules. You have full control of everything. The risk with doing that is that you may not be so relevant after a while, because most of the things that are happening in the Yang world are happening in another universe than your own. So if you want to be able to interwork and leverage technology and standards that are developed by others, it may be better to stay relevant and join a universe somewhere. So in the very early days of Yang, we had this sort of a naive approach. Okay, we thought, okay, let's model interfaces. That's going to be important, the core assets. So we started implementing Yang models that had interface by name, and then they had some state data on the same interface. So we had a configured interface. It could be configured into shutdown state if you wanted to, and it had a number of sent packets. But after quite soon, we realized then that, okay, there are some interfaces that may never be configured. For example, the loopback interface, nobody has configured it, but it still has a number of sent packets. So how can I read the number of sent packets in the loopback? Well, with this model, in model A here, you can't. If you don't configure it, it doesn't exist. So this soon led to model B here, where ITF as well as OpenConfig decided, okay, let's make two branches then. You have the interfaces part and the interfaces state part, where interfaces state reflects the things that actually exist on the system, including loopback, and the interfaces on the top there is what people have configured, and the set of interfaces that you see in one of them and the other are different. So that reflects the different life cycles of config and state. Problem solved. But then you have the robots coming around trying to make sense of this. And for a robot, it's not so easy to realize that, oh, so if I see sent packet 0 and I want to fix the problem, I want to go configure something, for example, unshut the interface, where should I find the interface to unshut in order to make sent packets start increasing? Well, to a programmer and to you and me that's looking at this right now, we realize quickly that, okay, you take the same name as you have under interfaces state, you put that name under interfaces interface, and then you go to the shutdown leaf there. But the robot is not able to do that. There's nothing in the model, nothing in the Yang that suggests that those two have anything to do with each other. It's just a convention that something dash state means, okay, you have a similar tree there with the similar keys, and they are thereby connected. So that was not an ideal solution, ITF thought. OpenConfig has gone down this route and thinks by specifying a particular pattern of modeling, that sort of hard coding that knowledge into all the clients. It has some merits, but it's also not ideal in all situations. So ITF, they went on with this sort of combined approach, model C here, where they modeled things all like the naive approach again, except that the name that's in the list here is not only config, but it's both in config and state. So, and then they added some new protocol operations that can say, hey, give me interface, everything is in there, seen as state. Or can you give me interface, all that's in there, seen as config. So with this is called NMDA, or Network Management Data Store Architecture. So with these new operations, you can make the models conveniently small and nice. Everything is located together, but it requires some new operations. But anyway, this is just here in order to illustrate how modeling universe B and modeling universe C may not be so easy to combine, where C depends on some new operations and B depends on some conventions that the folks over in the C universe don't tolerate. So that's how things get hard to combine. So that then brings us to the next thing, which is consistent module states. So what if you couldn't make up your mind about going with the ITF models and OpenConfig models? What if you need both? You have customers that say, we need this and that, or some customers say OpenConfig and some say ITF. Well, you can actually go and implement both of them. but you need to separate the open config modules from the ITF models into something that we call a consistent module set. So you just have to provide your customers with list. Oh, here are, if you want to go open config, that's fine. Here are the modules you're supposed to use, because it's going to be all the open config modules, but maybe also some annotations and extensions and deviations that you added. So it's not so super trivial, easy to know exactly which modules the open config module set consists of. But you as a vendor of a server, you need to specify this is the open config consistent module set, or ITF for that matter. But you can also use this technique if you are publishing overlapping Yang models. For example, you have an old module and you make a new version of that module that is incompatible with the previous. Well, then you can publish a set of modules that go together with the old view as native 1 and publish a new set of models as native 2. As long as the clients are using one of these particular sets, it's going to work nicely. But if they try to use all the models at the same time, there's going to be clashes. You have references to things that they don't configure and things like that. So this is another way of looking at picking your universes. So what about reusing someone else's Yang module then? The first thing you need to do is then select which Yang models that are relevant to reuse. You might know them already, but if you're not sure about which Yang models that are out there that are talking about some particular technology, or you can go to yangcatalog.org. It provides an interface to search between several thousand Yang modules that are out there both from standardization bodies and from vendors. So if you were looking what are the alternatives for managing BGP or whatever, you can search for BGP in there and see which modules that are talking about that sort of thing. Some modules also contain features, so then you can select which features that you're interested to implement. If you now go and select a few Yang modules, you say, oh, these are the right ones for what I need to do. You're sort of giving a sort of commitment towards those Yang models. So if that organization that is producing those Yang modules are releasing new versions of those Yang modules, it would be nice of you towards your customers and your users if you are sort of tracking those new versions as well. You don't need to do it the same day, but if you're lagging too far behind when it comes to versions, there will be version skew headaches for people that are trying to track your modules with some old version of this and other organizations' new versions. Things are generally compatible when it's reasonably similar in time, but if you are having some very old ones, it's going to be troublesome. And also, when you're importing Yang modules from other organizations, you have two ways of doing that. You can either just import them for getting access to the types or groupings that you find in there. It's called import only. If you do that, if you are importing modules in your Yang modules and you intend to only reuse groupings and types, make that super clear to the audience so that they understand, oh, I don't have to implement all of these other things in there. You're just taking a couple of groupings or whatever. So be very clear, please. And the normal thing otherwise would be to reuse the entire module. You implement the whole thing with all the containers and structures, whatever it is, RPCs and notifications. The typical things you do when you leverage another Yang model is you use leaf refs to point to things in that module. You can augment that other module by adding more content, Yang content to it. Or you might mount that module into some tree that you have. So there's a number of different ways of reusing functionality from somebody else's Yang module. And you can also work with extensions to extend meta-level information about these modules. Things you shouldn't do is you shouldn't go into somebody else's module and copy paste stuff from there. That is a copyright infringement and generally not a good software architecture method, because it makes bloated interfaces, and whoever is already having support for the original model won't be able to leverage that in your copy. The software will not recognize that this is the same thing. So copy paste is not a good idea. But reading other people's modules and getting inspiration from them is, of course, is very good. So the more you read, the more you get used to seeing how other people solve problems. So I think that's a great way of learning. And stealing high-level design is probably a good idea, making things look somewhat similar. If you are at the standards body, I'll add a few more things that you shouldn't do. If you say that, okay, I'm standards body X and I'm importing stuff from ITF, but I don't need all of that. So something that's is not optional in the ITF module, I say in SDO X here, no, you don't need to implement that. That is problematic. It's causing headaches for people. So if you want to be nice to your users, don't do that. Or similarly, if you say that, oh, so this particular leaf over here is declared mandatory by ITF, but in our use case, it's not important, so you don't need to do that. That's also clashing between the organizations, and it's not going to be easy for your users and for your takers of your standard to work with that. And much of the same reason, don't use deviations at all if you're a standards defining organization. You should not deviate your own models. You should not deviate anybody else's models. If you import data from ITF and start deviating that, the poor user or the poor client of your standard models now have to choose between implementing it faithfully as ITF requires or as you require, and they cannot do both. And that precludes a lot of use cases. Maybe they want to use functionality from some other modules that also depend on this ITF module, and now they can't because they have to pick sides. Don't use deviations if you're an SDO. If you do reuse models, that's very nice for your users because they might already have software or systems that understand these types and modules and stuff. So then that's real software reuse for them. So they will be very thankful that you are not inventing something that's just similar, but actually reusing the exact same module. When it comes to the actual craftsmanship in Yang, there are a few things I've seen lately that I want to bring up for general discussion here. And one is the meaning of paths in Yang. So here you can look at this model up in the right corner. You see you have a structure with cards and a list of cards. Each one is keyed by an ID. Each card has a number of interfaces keyed by a name. And some of the interfaces, they have parent interfaces because they are virtual kind of interfaces. And so they are pointing to interfaces somewhere. And you have the PIF name, it's a leaf ref pointing to name. And the question now is, how should we implement PIF name, this leaf ref, so that it actually is useful in this context? And I give you 6 different potential implementations of this leaf ref here below. A, B, C, D, and E, and F. They all point correctly to name, I believe, but they don't do the same thing. They don't mean the same thing. But can you figure out here, look at A, B, C, and D, and E, F, and see which of these ones mean the same thing? And I'll give you a few seconds to ponder this, and then I'll tell you. I'm afraid that's all the time you're going to get. I don't know if you get 5 seconds each to consider what it means, but here's the answer. If you look at path A, it means the same thing as path D, which basically means it's a reference to any interface on any card. It allows you to fill in the PIF name any name that exists anywhere on any interface on any card. Where A is, of course, an absolute path and D is a relative path, but the relative path is going all the way up to card and then down to name again, which makes it free of this instance, so it can point to anything. B, on the other hand, it's just going 2 levels up from the PIF name. That can only point to a single value, namely the interface itself, which is probably, unless you want to make this interface a parent of itself, it's probably not what you want. And C and E and F, they all mean the same thing. C, because it's going just up to the level of interface and back into name. So that makes it point to any interface on this card. And E and F, they are doing the same thing. E by going all the way, relative path all the way up to card, but adding a predicate, a filter, to say, well, only those that have the same ID that my card has. So it's going out of card and back into the same card again, and saying, okay, any name in there. And F by using an absolute path, which takes in the whole world, but applies a predicate, a filter, for only the particular card that I'm on right now. So any interface on this card. So depending on what you want, what you mean, it could be A or D that is a reasonable implementation of this, or C, E, or F. B is unlikely to be what you want. But they all point to name. Next slide is a similar thing, because I see that it's quite common to have problems pointing correctly when there are multiple keys. As you saw on the previous slide, we had a case where we were pointing to a name where it could be on any card and any interface. But since we have 2 keys there, that's if the interpretation of that leaf ref was that it should point to anything on any card, it's kind of underspecified, because PIF name could contain the value, for example, E7, but E7 might exist on card 4 and on card 5. And if it matters which, if we mean E7 on card 4 or on card 5, if that is important to understand which one we're pointing to, that model was underspecified. If we only pointed to interfaces on the same card, of course, then that was good enough. But here, when we want to point to something on any card, on any interface, then we need 2 references, 2 leaf refs. So I introduced a new PIF card and PIF name. Both are leaf refs. PIF card, of course, should point out which card this interface is on. So it's just a simple leaf ref. Well, any card ID, that's just fine. But I give you 4 approaches to 4 possible values for the leaf ref for PIF name. I'll give you a few seconds again to consider which ones of these 4 are reasonable implementations to do what we want here. Well, A and B are broken. C and D do the same thing, which really they point to any interface on the card that's pointed by PIF card. That's what we want. PIF card points to which card we want this interface to sit on, and PIF name allows all the names of interfaces on that particular card. The alternative C is doing that by using an absolute path with a predicate, the filter, saying that, okay, and the card ID needs to match what I have configured in PIF card. And D is using this Yang 1.1 deref function, which makes it a lot simpler, actually. Just say whatever PIF card is pointing to, PIF card is pointing to card ID, go 1 level up into interfaces, interface name. deref is a very nice function. It reduces the size of these paths quite significantly. What about alternative A then? It's an absolute path that points to any interface on any card. So PIF card could contain the value card 5, and PIF name could contain E7, but there's maybe no E7 on card 5. but still a valid value according to this Yang model with this path statement, because there is an E7 on card 4. So that's a little bit too free. And B is even more broken, I'd say, because it's pointing to any interface on the card that's pointed out by, that's on the same card as this particular interface that we're defining. So it's disregarding PIF card entirely and just pointing to any interface on the card that the parent interface sits on. Well, another few cases that are often mixed up is the difference between NP containers and P containers. NP containers stands for non-presence containers, which is meaning perfectly fine, normally ordinary containers. Nothing special about them. Containers in general are NP containers. From a logical perspective, NP containers, normal containers, they always exist if their parent exists. And a lot of people find that confusing or surprising. To contrast that with P containers, which means presence containers, those are containers that can be explicitly created or deleted. So if you look at this container BGP below, let's assume that this container BGP is at the top level of a module, and has the root node as a parent. If this present statement in green is not there, container BGP will therefore exist always, because it's an NP container if the green is not there, and the parent is the root, and root always exists. And that means that the leaf AS number always exists, and that's a mandatory leaf, which means that we have a value that needs to be specified at all times in this configuration. The blank configuration is not valid. And that's a problem because, okay, maybe if on your system here, your server, your device, you always want to have an AS number. But for example, for NSO that wants to manage this device, before NSO is connected with this device, it will treat the configuration as blank. And that means that you cannot really add the device to NSO in a simple way, because it needs to have a value for the AS number immediately, because otherwise the configuration in NSO would be invalid. And the same thing, what if you have a day 0 configuration, you want to boot the device, you'd have to fill in an AS number. The blank configuration would not be okay. So what you should do then, in order to fulfill this recommendation from ITF that the empty configuration should be valid, is to add the presence statement to the BGP container. That turns it into something that's optional. The BGP container will then not exist in the blank configuration. It will just say, oh, it doesn't exist, and that will make the AS number not exist either, because the parent, the container BGP, does not exist, and that solves that problem. And the logic would be that, okay, when you create BGP, of course you need an AS number. BGP cannot function without an AS number. But if you don't have BGP enabled, the AS number doesn't matter. Another case I see a lot is leaves being declared, and they have no default value. They are not mandatory, and they have no particular description that describes what they mean when they are not there. For some leaves, the interpretation, for many leaves, the interpretation when they don't have any default or anything is intuitive, but some of them are quite tricky. For example, what does it mean if the leaf enabled, which is type Boolean, does not exist? It's not configured. Is the feature enabled or is it not? I mean, if the leaf enabled has value true, I suppose it's enabled, and if it has the value false, I suppose it's not. But if enabled does not exist at all, I'm not sure. And there I see 3 ways of solving that. One is to use the description statement to write down, okay, if this leaf does not exist or is not configured, this is what's going to happen. For example, automatic mode will figure out if this one should be enabled or not. And then you can force it on or force it off by configuring it to false or true. But if you don't set it, the system will decide. Or you can declare, as in case B here, you can declare default false. If you don't say anything else, I will assume false. Or if there is no reasonable default, you can go with variant C and say it's mandatory true. Don't do that on the top level though, but if you declare a leaf like this, mandatory true, it has no default, and it will force the the operator to set a value for it. In all three cases, we remove all the ambiguity of what it might mean when the leaf doesn't exist. Then we get into module versions. That's a hot topic in ITF right now. There's a sub work group in the NetMod working group that's trying to work out the next steps for versioning of Yang modules in ITF right now. And they have produced a number of drafts. If you want to read up on this, there's plenty of things you can read. So I'll give you a brief version of the theory that's currently employed by ITF. Let's say you have a server provider that's releasing a Yang module, release 15, in which there is a speed leaf of type int. But in the next version, they realize, we can't just have a leaf speed. We need to have separate up speeds and down speeds. And since that is not backwards compatible, they keep this leaf speed and declare it deprecated. But in a separate module, so that it doesn't have the same namespace, they declare the leaf up speed and down speed. Now, a client would be in trouble if it's trying to use both modules at the same time, both speed and up speed and down speed, because they interfere with each other. If you set speed, that might affect both up speed and down speed. And if you set up speed to a different value than down speed, it may translate strangely into speed. Exactly what should you do there? Should you take the average, the sum? It's kind of unclear what you should do as a module implementer. So if you keep these modules separate and make one consistent module set with one module and another consistent module set with the first module, things will be fine. And then in release 17, we can of course remove this leaf speed entirely, either by keeping it with status obsolete. Status obsolete means that it's probably not working anymore, but it's still left here in order to ensure that no other leaf or thing is created in this model at this location by name speed. I mean, if you removed it, it might look like, you could invent something with the name speed here. So it may make sense to keep the leaf in there with status obsolete, just as a placeholder. But it won't work anymore. And then you have the leaf up speed and down speed to really work with the speed there. So this is the sort of theory ITF suggests. This is how you should do things. And you can also, in R17, you could delete the old module there entirely. If there's nothing else in there that makes it important to keep this module, you can just drop that module entirely. Still be following the ideas here. From the client side, from the manager, the client would see this R15, 16, and 17 coming from the organization that's providing this. And in the beginning, the client would use the speed leaf, of course, because there's nothing else. And as R16 comes out, speed leaf is still there. So you can go ahead and keep using that for a while. And then you have two different scenarios. The clients in scenario A, they decided, okay, let's upgrade all our equipment to release 16 and remove all existence of 15 in our network. And then we can change our client. When that's done, we can change our client to use the up-down leaves instead. That's a simple and nice way of upgrading if you can afford upgrading all your equipment to R16 before you upgrade the client. But that is often not the case in the real world. So in that case, you might upgrade your client so they can deal with the existence of sometimes it's speed and sometimes it's up and down speed, depending on which device you're talking to. If the device over here happens to be in R15, it's going to be speed. If it's R16, it's going to be up-down speed. And by the time that R17 is released, and this client might hit R17 devices that don't have speed anymore, this conversion of the client code needs to have happened already so that we can deal with both worlds in that case. So this, you can see R16 is basically a backwards compatibility retention window. During this time, the clients will have to deal with this compatibility issue, backwards compatibility. And I would like all of us in the NetConf Yang industry to start talking more about this retention time. It's everybody realizes when they think about it more deeply that it is here, but it should be advertised more clearly, in my opinion, by all the standards organization as well as vendors that are making Yang models. What is our policy around this retention time? How should we treat it? Because not all vendors do a good job of that, and I'm afraid Cisco is one of the perpetrators sometimes. So in reality, things are of course much harder than this. This is the theory, right? The mechanism that IETF has invented to handle version compatibility. But as a network owner, what do you do really in reality? Do you upgrade all your servers first, all the devices, and then the clients, just like example A there? Or do you upgrade all your clients first so that it can handle this new situation? And then when the new situation is there, then you start upgrading your servers. Or do you upgrade some of the servers, basically devices, and then all your clients, and then the remaining servers? Or is it more like you upgrade some of the servers, some of the clients, and then you keep repeating that for some time, or it's more unclear than that? I'd say that when I speak to network owners, reality tends to be towards the lower half of this list. And when I speak to Yang module implementers, it tends to be more. So there's a sort of gap between reality and theory here, I'm afraid. And to make it worse, in the real world, there is typically more than one manager, more than one client. And yes, of course, CLI operators that are still working in the networks, they would count as clients here. So that makes it quite obvious. There are more than one client. You have automatic systems, and you have people, and you may have more than one automatic system that's doing things towards these devices. And as soon as one client starts to use this new cool functionality of the new release, it won't be backwards compatible to the other clients anymore. So let's say here you have a leaf frequency that used to be an enumeration with the values high and low in the older model that we upgrade so that it's high, low, and auto. That's fine. All the clients can still work in this scenario until some operator or system decides to use this auto feature, because then all the older clients, all the other clients that have not upgraded yet will be suffering. Will say that frequency is auto. They don't have a clue what that means. They will think it's invalid value. So in practice, in the real world, where there are many managers, backwards compatibility concepts are not quite as simple and easy as they tend to be on paper. And even so, here we talked about vendors and organizations that are following the compatibility rules exactly, but that is also not happening all the time. People are not always following these theories, and sometimes they do, but the backwards compatibility retention time is very short, or basically non-existent. You go directly from something that's you need to upgrade all your clients at 0 time or something like that, or very quickly. So I guess this is part of the reason why IETF is working so hard right now on updating version compatibility rules. But even if they're updating the rules, the real world is gorier than that. Yeah, so this is supposedly a backwards compatible change, but in real life, it may still cause harm if you have multiple managers, multiple clients. And my final slide here, before you go publish your modules, please be sure that you're reviewing it properly, both using tools for syntax checks and stuff, but also having real people actually review it, both people who understands the subject matter of this module, understands how it's going to be used, and also, if ideally, if possible, some Yang expert reviewers, so that the Yang is actually reflecting the intent, because we see quite a lot of modules that are being released that are where the intent is not encoded in proper Yang. And you can find tools to validate, for example, on the yangvalidator.com and yangcatalog.org, regexpress and entire Yang modules. And a lot of people, they say, but we have validated our module using Pyang, and we are using the strict -- lint mode, so it must be really good, really well checked. We are following all the rules. Unfortunately, that validation is pretty weak. Even in strict and lint modes, Pyang is not doing a very thorough job, and it won't even look at XPath expression. So if you did anything wrong in XPath, as you saw on the previous slides, there's ample opportunity to do. It won't be reflected there in any sort of error codes and something. So with that, we are at the end of the presentation. I'd be happy to take any questions that are not answered yet, and maybe we should take a look at this poll as well. Nabil, maybe you can take the poll.
Well, let's. We have plenty of questions to answer. Maybe we can go with those first, if you don't mind.
Yeah, please.
We have several of them. So I think that the first one was with regards to schema mount. Is there a tool that can visualize the Yang tree, including schema mounts? That
I'm not aware of. Yes, I'm not aware of any such tool right now, but it's bound to come out soon. But you can, of course, manually mount a tree view of this. So, I mean, it's possible to do, but it requires manual work right now, as far as I know.
Okay, cool. Next question is, assume we have an OpenConfig Yang for feature A, and we have an ITF Yang for feature B. And assume both of those Yang models import ITF interfaces.yang. I think this references the OpenConfig interfaces.yang probably. But the version of ITF interfaces are different in each model. So what are the options left in this case?
Yeah, and that's a double complication. Okay, the first answer is that you should make some consistent module sets so that you say that this set of modules here is what you use for model universe A, and this other set of modules here is for set B. There's of course quite possible that some of the modules are in both sets. It's quite okay. For example, ITF interfaces might be in both. But if they are very different versions so that they are incompatible, well, this is going to be problematic. It's not, I mean, you can probably take the later version. If they are backwards compatible, go with the later version, because, for example, ITF pledges to keep things backwards compatible. So if you take a later version of ITF interfaces than the one that was imported by the OpenConfig modules, it's probably going to work anyway. But yeah, it's difficult when you try to do that.
Okay, cool.
There are workarounds you can do. We have seen people do things that can sort of work for this, but it's let's not go into detail right here.
All right, cool. Thanks. Next question is, which is the best method to hook a third-party Yang model to the existing Yang tree? Let's say you have A, B, C, D, E, F tree structure, and then you want to hook something else, like a third-party Yang model X, Y, Z under C. So I believe this is referring to the schema mounts RFC, right?
Yes, I mean, schema mount would do exactly that. If you want to put a Yang model somewhere deep down in the tree somewhere, the only option you have is schema mount. But yeah, I should point out then that schema mount is pretty young, and there's a whole lot of tools, including those from Cisco, that don't support it properly. So it's bleeding edge, I'd say, to do that. But you can, of course, again, you can, using manual methods, make that sort of thing happen anyway. So there are workarounds, if you like.
Can you just mention one of those workarounds, Jan, just for completion here?
Yeah, I mean,
what would be manual work?
Yeah, that would mean rewriting that, taking a copy of that Yang model, rewriting it so that it augments the right place and stuff like that. Logically speaking, it would work, but of course, it is a sort of hack to make it go into the right place. Yeah. And for some modules, that may be a lot of work. It's not so easy always.
Okay. can you touch on the module semantic versioning approach as used in OpenConfig and ITF module versions? I think this refers to the draft verd t netmod yang semver, the semver draft.
Yes. So, I mean, as I mentioned earlier, and as whoever asked the question apparently knows, there's a lot of work going on in ITF right now about what to do for versioning in the next coming year or so. And there's a number of half a dozen drafts about versioning and version related topics that has been submitted and being discussed. Probably not all of those will go through, at least not in the current form. That's my interpretation, but some of them will. And one of them is this semver numbering. So ITF is considering using the same sort of number schemes as OpenConfig with 3 digits, like 1.0.0 and 2.1.1 and so on, for tracking compatibility between backwards compatibility between versions of the model. Having said that, I mean, it's kind of nice to have these sort of version numbers on models. It conveys compatibility claims in a very compact form, but reality is always complicated. So it's not easy to convey a full picture of how much one module is compatible with another version of that module in just 3 numbers. You will lose information in that conversion to 3 numbers. So you will not get a full picture, but you will have an idea of how compatible it is, sure. And that's a good thing.
Cool. I think this leads to the other another question regarding backward compatibility retention time. What is that in general? What's the backward compatibility retention time? I believe here by retention means how or when can you start introducing backward incompatible changes? Is that it, or?
Yeah, my idea with that concept was that how long time do I have as a network owner from the time I get a particular new version of something until I have to do something in my network, in my management infrastructure or whatever, because that feature is now going away. So how much forewarning do I get? Is that 6 months, a year? How long time do I get in order to? I mean, if you look at a typical operator network, you have thousands of devices out there, and they're not running all the same versions. Some of them are older, some of them are newer. And how long time from the time when I get a new version somewhere, how long time can I expect? How long back in time can I expect things to be compatible from a management point of view? Because when they are not, I need to react and do something in my software. And most operators, they would like to have a time of several years, and most service providers, they would like to have that like 6 months or something. So, but the main problem is not so much, in my opinion, how many months or years that is, but it is that it's not being communicated. People are not talking about it. It's something that you find out by trial and error. Oh, suddenly I upgraded this, now it stopped working. How come I didn't know? Oh, it's because this feature has a retention of just 1 release, 6 months.
Cool. Thanks. Another question is with regard to Tosca. Do we have Yang models for network services like Tosca?
I think there are. Yes, I have seen Yang models for Tosca. I don't know how official they are by Oasis, but I saw that several years ago. So it's somebody took the effort to do that. I am not up to date with the latest there, but in principle, I see no problem at all having Yang models for the Tosca functionality. Actually, it would be really good.
Okay. This question is more, I think, company specific, but this is the last question. Basically, by mistake, as the question says, by mistake, we are compiling annotation modules and including them in the database. Will we gain a substantial speed improvement if we stop doing this? I don't see a way around that. I mean, if the annotation modules are, I guess maybe this is in comparison with inline, to define things inline, as opposed to using annotation modules. Does anyone know?
We're talking about the compilation time now. Is that it?
It mentions speed improvement in general, so I believe I don't know. I'm not sure about this question. Maybe you can clarify, Jaka. Okay, maybe we can, while we wait for clarification, the next question is, since we don't have much time left, does deprecated leaves have retention time specified in the Yang model, in the description? Or basically, maybe this is the good practice or the best practice in this area that you talked about retention time for backward compatible changes earlier.
Yes, no, I haven't seen that. I haven't seen that, but it may be a good idea to put it in there next to that leaf saying, oh, this is deprecated, it will go away in release 5.4. That could be one way of doing it, but maybe even better to not have that by individual leaf, because that would be hard to track. Oh, there's a leaf over here that we are using that has retention time like this, and there's another one over here that's much longer. So it may be more of a general policy that's organization XYZ that releases a model says, yeah, we pledge to have a retention time like this, or at least 2 releases, or I don't know exactly how to communicate that, but to declare a policy there so that everybody knows how long time things are compatible.
Okay. Can Yang support arithmetic operations in operational mode? Let's say you have leaf A, leaf B, and leaf C, which is A plus B. Is it possible to do the addition part in runtime?
Well, all systems do things like that, but it's not related to Yang. It's somebody who implements this Yang module would certainly implement arithmetic if that's what it takes.
Right. So it's not a Yang feature. It's not part of Yang.
I mean, you can of course have a constraint that says that leaf C needs to be equal to the sum of leaves A and B or something, and it's a constraint, and you can do that in XPath certainly. Or the sum of the columns such and such in this table needs to be 100 or something. You could do that if you want.
Okay, cool. I think we have 1 minute left here. I'm just trying to see if there is another questions that I can ask you, Jan. Okay, so the rest of the questions are mostly Conf-D related, and I'll make sure to answer those questions later on. So with that, I think we reached the end of this presentation. I would like to thank everyone. Thank you, Jan, for a great presentation today. I will send the recording and the presentation slides, of course, to everyone, and we'll follow up on the unanswered questions. So, but please, if you have any questions to me, you can reach out to me directly. I'll be happy to follow up. All right. Thank you.
Thank you very much.
Yep. Thank you.